All right, so today we're going to finish talking about how to solve triangles. Okay. Using law of sines, we were able to solve three types of triangles. Okay. Side angle angle, angle side angle, and side side angle. Okay. This is what last week's test was on. Okay. This week we will not be solving these kinds of triangles. Okay. These letters refer to the information that's given to you, okay, and where it is. For example, angle side angle means you know two angles and you know the side that's between them. Okay? So you might have something like 100 degrees, 15 degrees, and that side is 12. Okay? That's an example of angle side angle. Okay. Law of cosines enables us to solve two other types that we didn't have listed here. Well, let's talk about angle, angle, angle for a second. If you knew all three angles, could you figure out the sides? Like, for example, if I said I have an equilateral triangle, all the angles would be 60, 60, 60, 60. Do you know the sides? No. What could they be? It could be anything, right? Could be, if it's equilateral, it could be 3, 3, and 3, or 5, 5, and 5. So we can't solve angle, angle, angle. Every case has to give you at least one side, sometimes two, sometimes even more. Okay, so what do you think, what are the other two cases we could have? Just arranging those S's and A's, yeah?
Side, side, side.
Yep, side, side, side is one. And law of cosines is going to be used for that. And there's one more. Yep.
Side angle side.
And side angle side. Okay, those are the two cases that we can solve with law of cosines. Okay, side angle side looks like this. It's where you're given two sides and an angle, but the angle is between the two sides. If the angle wasn't between the two sides, okay, then it becomes a problem we did last week. Side, side angle. And that's the case that we don't like to deal with law of sines, because you could have 0, 1, or 2 solutions. Okay? We didn't do a lot of work with the 2 solution case, but if we can avoid this case, we try to always avoid it. Okay? And we're going to be able to with law of cosines. Okay? And there's the other case, side, side, side. Now, side angle side always has a solution, always. You could make this left-hand side as long or short as you want. You could make the bottom side as long or short as you want, and make the angle anything you want between them. And you could always form a triangle, okay? Because this angle at the top, this angle on the right, and this last side are undetermined. Okay, so you could always make a triangle with side angle side. But side, side, side might not always be a triangle. Okay? Does anybody remember what the rule is about if you add up two of the sides?
It has to be shorter than the other.
It has to be longer, yeah. Okay, if you add up two sides, it has to be bigger than the third. If it's not, then you don't have a triangle. So for example, if they gave you sides of 1, 1, and 10, that's no solution. Okay? Those other two sides are too short. They don't add up to more than 10. All right, this example works fine. 10 plus 8 is bigger than 7. 8 plus 7 is bigger than 10. And 10 plus, whichever one I didn't say. If you add up any two, they're bigger than the third. Okay? Any questions on that? So always check for that before you start solving a side, side, side. Okay? All right, so let's look at this one. And before we start to solve it, I'm going to give you the formula for law of cosines in a minute, but I want to see why we can't use law of sines. Okay, so to determine if it's law of sines using the SAS or side, 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 you'd have to draw a picture. But does anybody remember looking at the table? I said you have to have a row that what? that's full, right? You have to have a row that's complete to use law of sines. Do you have a row in this table that has everything in it? No. Okay? Just because of that alone, it tells you it's law of cosines. Okay? All right. So I'm just going to put since we do not have complete row, okay, we use law of cosines. And there's only two types for law of cosines. There's side angle side and side side side. Based on the information in the table, which one does it have to be?
Side angle side.
It's got to be side angle side. It can't be side 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 because you don't know C. All right, so let me show you what law of cosines is. Okay, the proof, we're not going to go through the proof. Okay, I have another video if you want to see it online. It's pretty short. It only takes about 2 or 3 minutes. But I think we're gonna skip over the proof, and I'll give you the first version of the law of cosines, and then maybe you guys can give me the second and third one, just based on rearranging letters. Okay, so it kind of starts out like the Pythagorean theorem. A squared equals b squared plus c squared. But we can't use Pythagorean theorem in these kinds of triangles. Why? Why can't we use the Pythagorean theorem? Or what are we missing to be able to do that?
Because they're not right triangles.
Right, they're not right triangles. Okay, so we know this can't be the whole formula because this is the Pythagorean theorem. Okay? So what we have to do is we have to subtract something. Okay, there's an adjustment that we have to make, okay, on the end. And that adjustment in this version is 2bc times the cosine of alpha. Okay, and that's one version of the law of cosines. This is the version that starts out a squared. Okay, and then there's one that starts out b squared and one that starts out c squared. They're pretty much the same formula, just rearranging things.
So the b squared divided by a squared.
We'll take a look in a second what they are, but it's going to follow the exact same pattern with pluses and minus signs. It's just the A's, B's, and C's are going to move around. Okay, but first I want to just take a look at this top one. If we had a right triangle, okay, as Brendan mentioned earlier, what angle would we have guaranteed in a right triangle? You have a 90. Okay? You'd have one angle that's 90. Let's see what happens if we make alpha 90, okay, and take the cosine of it. Okay, what did I get? So if I had a right triangle, this would be cosine of 90, which would be 0. And what's 0 times anything? 0. So what would happen if we had a right triangle? This whole part on the end would disappear. We wouldn't need it. And then it would be just like the Pythagorean theorem. Okay, but when your angle is not a right triangle, when it's not 90, and you take the cosine of something not 90, it's not going to come out to 0. Okay, and then we're going to need this part. All right, let's see if we can get the second version of the law of cosines. Following the same pattern, it's just the two letters here are going to switch. Brendan?
A squared plus c squared minus 2ac cos beta.
Yeah, cosine beta. So the pattern is one side squared equals the sum of the other two squared, minus twice the product of the other two, times the cosine of the angle that's across from the side you start with. Okay, if you can remember that, then you can call your sides whatever you want. Especially in a word problem. You might be given a diagram that's not labeled A, B, and C. So when that happens, you just have to understand kind of the general idea of the theorem if you don't have the exact letters we're using. All right, and anyone think they can give me the last version? Yeah?
B squared plus C squared minus 2AB.
As
Does anyone remember the angle across from C? So we got the whole formula, we're good. We just need Yep. Gamma. Okay, so these are the three versions of the law of cosines. Okay, all the same thing, just rearranged a little bit. Now, when you have a side angle side problem, you have to start with one of these versions. Okay, let's call them version 1, 2, and 3. Which version do you think I have to use here?
A. C.
Which one do you mean by that would be?
3.
Version 3, yeah. Okay, they all have A, B, and C in them. Every formula has every side in it. Okay? So the problem is you're already missing C in every formula right now. You can't be missing anything else. So if you picked version 1, you'd need alpha, but you don't have that. Now you're missing C and alpha. If you pick version 2, you're missing C and beta. But if you pick version 3, you know gamma, and you can fill that in. Okay, so with a side angle side problem, you have to start with a certain version. And then after that, you can pretty much solve it any way you want. Okay, but we have to start with version 3. Any question on that? Okay, so let's fill into version 3. So we've got C squared. Okay, and we're going to find C right now. So C squared equals A squared plus B squared minus 2 times A times B. And some of these steps we can do in our head as we're writing it. But for the first time through, I'll just write it all out. Cosine of gamma. Right, now, this is more of an arithmetic problem than it is algebra. The variable's already by itself on one side, with the exception of just taking a square root at the end. Okay, but we have to do all this arithmetic out and follow PEMDAS. Okay, so what's the first thing I would do on the right-hand side?
Parentheses.
Yep, if we had parentheses, we would do that. And then what's the next thing?
Exponents.
Exponents. So let's do our exponents. 4 squared is 16. 7 squared is 49. Now, if we want, at the same time, we can do our multiplication. Okay? Because we've done exponents. But if I didn't do anything else, I would just copy down the rest of it, and then I would just have to write it again to do the multiplication. All right, so what's 2 times 4?
56.
And then 8 times 7 is 56. Cosine 42. Now you might say, well, wait a minute. Why did he do? Why did he do that first? Why didn't he add the 16 and the 49? Well, I could, but if I'm following PEMDAS, I do my multiplication, and then I'll do any addition. Okay, but it's true. Adding these two together doesn't have any effect on the 56. Okay? Why don't I do 49 minus 56 here?
Where is that? The addition.
Yeah, let's do the addition first. Right? What's 16 plus 49?
65.
So now I have 65 minus 56 cosine 42. Okay, so that's fine. Now, what should I do next? My subtraction or this multiplication? Yeah. And it's okay that we added 16 and 49, because this 65 is separated from the rest of the problem by a minus sign. Okay, so adding these together first didn't affect what we are about to multiply. It's 56 cosine 42. It was always 56 cosine 42. Okay, we didn't affect that. Okay, so let's do that next. 56 cosine 42. Because we're in degrees, make sure you check that first. All right, so 56 cosine 42. Okay, about 41.616. Okay, now we can do the subtraction. So 185 minus, and I'll just type in my answer that I just had on the screen. Okay, 23.384. Right, now that's not c, that's c squared.
Oh, then we have to do it.
So take the square root of that. It's a little less than 5. 4.836. And again, it looks like a lot of steps, but many of these we could have done in our head. And the next time we go through, I can do some of them in our head as we go. All right, so we got C. Okay, any questions on C? Yep.
And you get to paste your answer back down to the next one.
Oh, to use your last answer on the screen, just press second and then the negative sign. Yep. All right, let's sketch that and see what kind of triangle we have now. It was side angle side, but now we have an additional piece of information. Okay, so we had, let's make A alpha, B beta, and that'll be C and gamma. So there's the original information we had. 4, 42, 7, side angle side. Okay, what other type of triangle is it now?
Sine. Cosine. I mean sine.
Side. Yep, you could look at it as side angle. I'll come back to that in a second. And what other type? Side. If you look at it as a side or side angle side, we're going to use law of cosines one more time. If you look at it as side angle, okay, side angle was law of sines. But why do you think I'm going to avoid?
Because you're doing laws of cosines.
All right, because the lesson is on law of cosines.
But we don't have.
What don't I like about this case, though? If it came out to one of these other ones, I might do it. But it's not.
We're missing something.
Brendan?
Never mind.
We're missing that.
We're using an angle that we calculated, which could be a
We're using, let's see.
angle that we calculated. So it's not going to get into.
You mean a side that we calculated?
Yeah.
Yep, so we are using a side that we calculated. Unfortunately, we're still going to have to use that, even if we do law of cosines. But that's a good idea. It's always nice to avoid using something if you can, but we have to here. Okay. Why do I really just want to avoid side angle? Yeah.
Don't you use inverse sine for that?
Yeah. And what can happen when you use inverse sine? Yep.
Well, that's the-
Yeah, that's the thing where you got to deal with possibly no solution, one solution, or two solutions. All right, so there is only one solution to this problem. Law of cosines will give it to us automatically, and we won't have to worry about all that other stuff. Okay, so don't use law of sines to finish this off. I'm not saying you can't, you can, but you have to be extremely careful. All right, and people usually make a mistake. So we'll use law of cosines one more time. At this point, we know all the sides. You can use any version of the law of cosines you want. Okay, let's use the version that has alpha. Okay, so let's find alpha. Okay, so I don't have to scroll up and down if people can just tell me what A, B, and C. I have C, but what A and B are, that'll help. All right, so what's A?
4 squared.
So 4, and we're going to square it. What's B?
7 is 49.
So 7 squared, 49. Plus C squared I already have from the last part of the problem I just did. 23.384. Minus.
4.8.
Okay, I need 2 times B times C. So 2 times, what was B? 7? 7 times C, 4.836. So I just did 2 times B times C. I'm just going to double check that, make sure we're okay. 2 2 times 7 times 4.836. Yep, we're fine. Times cosine, what angle are we finding?
Theta.
Nope, not beta,
Theta. Alpha.
alpha. We're finding alpha. Right. Now this is not a PEMDAS problem. Okay, the variable is not by itself on one side. So now we're going to treat this like we're solving an equation. Okay? And if we get confused, what I'll do is I'll rewrite it without a trig function, like an algebra 1 equation, so you can see how to do it. All right. What would be my first step to solving this equation?
Moving 16 on the other side.
I would keep the 16 where it is. Okay, we want to move everything away from the alpha. Okay, we don't want to put more stuff with it.
Why can't we just change, put the cosine over on the other side,
Put the cosine.
on the 16 side?
Well, that cosine is attached to that 67 until we break off the 67 from it. So if we move it, we're going to have to add that 67.704 cosine, and that's not going to really help us to get alpha cosine by itself. Okay, we want to try to combine things first if we can.
We
Yep.
can add 49 and 23.384.
Yeah, we can combine like terms. Okay, 49 plus 23.384. Okay, so 72.384 minus 67.704 cosine alpha. Okay, now here is where we have to be careful. What would be my next step?
Moving 72.
Yes, move the 72 to the other side. And how do you do that?
Minus.
Minus the 72. Okay, a lot of people try to subtract 72 minus 67. You can't do that. Okay, this equation is kind of like this. 72 minus 67x. The 67 is multiplied by something you don't know. 72 and 67 are not like terms. Okay, so we're going to move the 72, and then we'll get rid of the 67. Minus 72, minus 72. Right, we got 16 minus 72.384, negative 56.384. And the rest of it's still there, negative 67 cosine alpha. Okay, what's my next step?
Get the cosine
Yep, we want to get the cosine alpha by itself.
and divide by.
Divide by,
Negative 67, 704.
divide by the negative 67, 704. Okay, so that's all gone. And this, I'm not even going to do this out. Because this isn't my final answer. I'm going to do something with it.
Wouldn't that be like, right, never mind. I thought you were subtracting it from both sides, not divided.
Yep, dividing.
Never mind.
Okay, I can cancel the negative if I want. But again, I'm not going to do this out, because if I do it out, I'm just going to be rounding off another calculation. And I've already rounded a couple times in this problem. Okay, so just leave it like that. What would be my, my last step?
Taking the inverse sign, or inverse cosine.
Inverse cosine. Okay, so on the right-hand side, I still have the cosine. Okay, this is all gone. But to get rid of cosine, I'm going to take the inverse cosine of each side. Okay, so the answer that I want is the inverse cosine of everything from up above. Over 67.704. Okay, now before I even type this in, I know that this has an answer. One, it's side angle side. It should always have an answer. But if I got to this point, and I could tell if there was going to be no solution, which shouldn't happen on this type of problem. What's the highest that cosine goes if you graph it? 1, and what's the lowest? -1. how do I know, forget about the decimal, how do I know if I divide 56 by 67? It's definitely less than 1. I know that. Yep.
56 is less than 67. That's
Right.
on top.
Yeah, the number on top is smaller. Okay? If you ever end up with the number on top larger, that's a problem. Something went wrong with the arithmetic. Okay? I know 56 divided by 67 is less than 1, so I know I can take the inverse cosine. Okay? Now we just need to do that out. Okay, so inverse cosine of 56.384 divided by 67.704. Right, 33,612. That's alpha. Now we have two ways we can get beta. What do you think one way I could get beta is?
Add together and then minus 14.
Yep, I can now add these two together. 42 plus 33.612. And now subtract that from 180. 104.388. Now, what do you think the danger about doing it the way that I just did it was?
If you were wrong with either your numbers, you're screwed.
Right? If I got alpha wrong, now I just got beta wrong. Okay? But since we have to use C for both, C is even more important. Okay? If you get C wrong, then alpha and beta are automatically wrong. But it is possible you get C right, you make a mistake with your arithmetic with alpha. But then if you went through the whole law of cosines again for beta, you might do the arithmetic right and still be able to get partial credit for, okay? So keep in mind, anytime you use something that you find, there's a chance you could get more things wrong if you make a mistake. But that is how I'm going to do it this time. Okay, if you have extra time, you can always check it with inverse cosine. Just do the formula that starts b squared. Do it out and see if you get 104.388. If the answer is supposed to be like 104.5 or 104.1, I would give you credit for that. But if it's supposed to be like 10, even if it's supposed to be like 105 and you got 104.4, if you're rounding to 3 decimal places, it shouldn't come out that far off. Okay, so if you're within a tenth, that's okay. But if you're like 6 or 7 tenths off, then something's not right.
How would you find beta again?
Well, the way we did it was add up and subtract from 180.
Okay, so 33 plus 42. Or,
Yep. Or set up the law of cosines one more time using version 2. That's another way to find beta. It'd be just like what we did with version 1, except the letters are rearranged. Okay, so any questions on the two ways you can find beta? All right. So that's our side angle side, the one we just did. Okay, which type is this one? Side, side, side. Okay, clearly side, 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 because you know all the sides. You don't have a row that's complete, so you can't use law of sines. Okay, if you want to try using the law of sines and look what happens. If you pick the first 2 rows, you're missing 2 things. That's no good. If you pick the last 2 rows, you're still missing 2 things. Can't do it. If you pick the first row and the last row, you're missing 2 things. You can't be missing 2 things. You can only be missing 1 thing. Okay, so we got to use law of cosines. Which version do I need to use here? Version 1, 2, or 3? You could use any of them. Okay? You know everything in every formula up to that line right there. You know A, you know B, and you know C. Okay? How many times are we going to have to do law of cosines at a minimum? At least twice. Every law of cosines problem, you have to do it twice. Okay. Find two angles and then add up and subtract from 180 to get the third. Or, if you really want to find everything separate, you could do law of cosines 3 times. And then, if you make a mistake on one part, it will not affect any other part. Okay? But to save time, the way I am going to do it is I'll do it twice and then subtract from 180. All right, so we found, we used the c squared version. We used, yep, the a squared. Let's find beta. Okay, just to practice using the b squared version. Right, and as I go, I'm gonna square some things. All right, so what's b squared? 49. A squared?
80.
C squared? 5. Minus 2ac. Let's do it in this order. What's 2 times c?
10,
Times 9?
90.
90. Cosine beta. Okay, what's nice about this one is because they gave us all the sides, usually they give you sides that are nice numbers, you're not going to have any decimals till you write the final answers. Okay? So you won't have to worry about any rounding till the end of the problem. All right. Do we add the 81 and the 25 or do the 25 minus 90?
81, 25.
Yeah, you can't do 25 minus 90. So 106 minus 90 cosine beta. Okay, next step. Can I do 106 minus 90 now?
Move 106 to other side.
Move the 106 to the other side. Good. You can never do 106 minus 90 because it's multiplied by cosine beta. Right, so we got 49 minus 106. That's negative 57. Negative 90 cosine beta. And my last step to get
Inverse.
cosine by itself first.
Move divide by 90.
Yep, I'm going to divide by negative 90. Now, at this point, if you divide 57 by 90, you are going to get a decimal. So don't do that. Just leave it as 57 over 90. Even if you can reduce this, which you can, they're both divisible by 3. Don't worry about doing that. Okay, just leave it as 57 over 90.
Question.
And the last thing Kyle mentioned, now we do our inverse cosine. Right, so inverse cosine of 57 over 90. Second inverse cosine, 57 over 90. Okay, so now we have beta. It's 50.704. 50.704. Okay, most of the mistakes I see in law of cosines, it's with arithmetic. People just make really simple mistakes and then they're like, I'm getting error, I'm getting no solution. Okay. And the ones on the test, I'm not going to give you no solution because I want to see that you can actually solve something. One thing I might have wanted to check first here, but again, I'm not going to give you one that's no solution on the test. Any two sides added together are bigger than the third. Right? That does work. Right, so now we've got beta. Now we'll do it one more time to either find alpha or gamma. Right, so which angle you want to finish up with?
Gamma.
Gamma. Right, so gamma is c squared, so that's 25, equals a squared plus b squared. 81 plus 49. Minus 2 times 9 times 7. 126. Cosine of, what are we finding? Gamma. Okay, now just do the same thing we just did. If you want, you could really do it all in one step. It's going to be 25 minus the sum of 81 plus 49 and divide by negative 126 and take the inverse cosine of that. Okay, but if you want to do it in a couple steps, we can. So that's 130. Okay, now I'm going to move everything at once. 25 minus 130. And then divide by what? Negative 126. And lastly, how would I get rid of my cosine? Take the inverse cosine. So really, the work for law of cosines can be very, very long if you show out every step. Or if you do some steps in your head, you really can do it in like 3 steps on paper. Okay. My advice, if you're going to do it like this, you have to be very careful when you type it in. Okay. If you don't like it like this, then do it like we did, 1 step at a time. So, inverse cosine of 25 minus 130. I want to do the numerator first. Then divide by negative 126. And then close my parenthesis for inverse cosine.
Wait, when you have a cosine inside, there's cosine.
I don't know. All right, so now put the numerator in parentheses, so it does that first. I think I meant to hit parenthesis and I hit cosine.
Okay.
And then divide by negative 126. Okay, so 33.557. All right, so safe way to find alpha, do law of cosines one more time. If you're pretty confident with beta and gamma, just add these up and subtract from 180. So minus 5704 minus 33.557. All right, so almost a right triangle. It's close, but not quite. 95,739. Okay, so any question on the law of cosines? All right, so last thing we're going to look at is we'll do a word problem with law of cosines. Okay, the diagram I'm going to help you out and already set it up for you. And then we'll look at one application of law of cosines, which is finding the area of a triangle. Okay, which is pretty easy. All right, so this one says a surveyor wants to find the distance between 2 points on either side of a house. And the surveyor has measured the distance from point C to A to be 110 feet. And from that same point to B is 160 feet. Now, one thing they give us in the diagram that they don't in the word problem is that angle. Angle ACB is 54 degrees. Okay, find the distance between points A and B. Now, if we want, we can just set up the equation, and if people are comfortable solving it from there, we can skip solving it. So we'll see. All right, now, in this problem, if it was just a house, I mean, really, you could probably just take a tape measure, measure up to the edge of the house, measure across the front of the house, and then just continue measuring from the side of the house again. But where something like this would actually be more necessary, like let's say you had a canyon between 2 points, a really huge canyon, and you wanted to know how wide is the canyon. Well, in that case, it's not as easy to run a tape measure across it. So using a transit or some kind of measuring instrument, you could find the width of the canyon. Almost take your transit, maybe set up like another tripod at point A and point B, and point a laser at point A, and then turn your tripod, and your tripod will track the angle you turn it for you, and then shoot a laser to point B, it'll tell you these distances, and it'll keep track of the angle you turn. So you could do exactly this if you had the right tool. All right. So this time, they've used A, B, and C for the angles. Okay, I'm just going to call this third side X. X is what we want to find. Okay, anyone think they could give me the rest of my equation? I'm giving you a hint how to start.
Side angle side.
Yep, it's side angle side. So what would be my equation to find X? Yep.
110 squared plus 160 squared minus 110, 160 cosine
Well, X is going to be our side, so we already know our angle, 54. One side squared equals the sum of the other two squared, minus twice the product of the other two, times cosine 54. All right, so I'll do the first step, and then if people need me to keep going, I can. So we got 12,100 plus 25,600 minus 2 times 110 times 60. $35,200. Cosine 54. Okay. Does anybody need me to keep going? Anybody unsure how you'd finish it up from here? You'd add the 12,100, the 25,600. Then you'd multiply 35,200 times cosine 54. And then you'd subtract. And your last step to get rid of this exponent would be square root. Okay, this is very similar to example 1, okay, where the variable is already by itself on the left, and you're just doing all the arithmetic on the right. Okay, so any questions on how to finish from here? Okay. All right, so let's take a look at our last thing, which is on finding area of a triangle. Okay, I'm going to show you two formulas to find the area of a triangle. One of them directly relates to law of cosines, which is why I'm showing it to you, since we're studying law of cosines. The other one is just a formula for area of a triangle, and it doesn't relate to law of cosines. Okay. But since it's on area of a triangle, I figured I'd show you both. Okay, the first formula I'm going to show you does not relate to law of cosines. Okay, the second one will. Okay, so I wrote down the formula for area of a triangle. Area is 1/2 base times height. And this formula is all you need, as long as you know what two things.
Base and height.
Yeah, you need the base and you need the height. But if they give you a problem like, find one, like that, find the area, you know the base. This 3 isn't the height because it's not straight, it's off at an angle, and you know an angle. Well, it's actually very, very easy to find the area of this triangle. Right? What we're basically going to do is figure out the height. Okay? And we're going to do it by coming up with a formula, so the formula does it for us and we don't even need to think about it. All right, so let's say we have this triangle. What I've done is I've drawn a dotted line in for the height. And I've labeled the sides A, B, and C. By drawing in a dotted line for the height, I created 2 right triangles. Okay, and that's going to help us. I want to focus on that angle, that side, and that side. What's the name of the side that's H? Would it be opposite, adjacent, or hypotenuse? Opposite. And what about side C? hypotenuse. And what trig function involves opposite and hypotenuse?
No.
Cosine is adjacent over hypotenuse. Sine. Sine equals opposite over hypotenuse. H over C. Now, I want to get a formula for H. So how would I move the C to the other side? Multiply by C. C sine alpha. That is my height. Okay, C times the sine of alpha. So as long as I know one side, C, I know the other side, the base, B, and I know the angle between the two sides, I can very easily come up with a formula for finding the area. Okay, so the area is 1/2 the base times the height. But don't write H for height, write C sine alpha. And that's it. That's the formula for the area of a triangle. 1/2 BC sine alpha. And now there's 3 versions of it, kind of like law of cosines, just switching around our letters. So I had B, I had C, and the angle between B and C. Anybody think they can give me another version?
1/2 A times C sine beta.
Yep, 1/2 AC sine beta. Okay. You've got A, you've got C, and beta would be that angle right there. And the last version, 1/2 A, B sine alpha, gamma. Okay, so it's helpful just to try to remember the general idea. The area is 1/2 the product of two sides times the sine of the angle between them. Half the product of two sides times the sine of the angle between them. Why do you think knowing the general idea is going to be helpful in example 3? Rather than trying to figure out which one of the 3 versions to use.
It's going to be 4. Is it 4?
Is it 4?
No.
How come in example 3 you have to understand the general idea rather than try and pick out one of those 3 versions, Brendan?
Because there are no labels.
There's no labels. You don't know what side is A, B, or C. So I can't tell you which version of the formula we're using. All I can do is say, use that general idea. Okay. And so anyone think they can give me the formula for the area of this triangle? John?
It's 36. Oh, no.
Well, that's going to be part of it.
Yeah.
So it's what do you do first? The area is half.
Of 3 times 12.
Yep, half the product of the two sides.
Degrees.
Times the what of 105?
Sine.
The end of
Sine. Okay, so half the product of the two sides times the sine of the angle between. That's it. Now just type it in and see what you get. Okay, so as John said, 3 times 12 is 36. Half of that is 18. So I'm going to do 18 sine 105. Okay, so the area is 17.387. And we don't know the label, if it was inches or feet, but we know its area. Just label it square units. Okay, it's a pretty quick, pretty straightforward way to find the area of a triangle if you know two sides and an angle. This method has nothing to do with law of cosines. It is a side angle side triangle, but you don't need law of cosines here. Okay, any question on that type? Okay, so side angle side. Okay. The other kind of triangle we studied is side side side. And if you want to find the area of a side side side, you can use Heron's formula. This formula comes from the law of cosines. The proof of this formula is pretty long. Okay, so we're not going to go through the proof. Okay, it is in your book. Okay, but the proof comes from law of cosines, and it says the formula is the square root of s times s minus a, s minus b, s minus c. So in general, it's s times s minus every side. So we know A, B, and C are the sides. Any guess on what S is? Nope, it's not an angle. I'll give you a hint. It's based on the sides. It's half of A plus B plus C. What's A plus B plus C? It's the perimeter, right? If you add up all the sides, it's the perimeter. And if you take half of it, it's half the perimeter. Well, we call half the perimeter the semi-perimeter. Okay, that's where the S comes from. So it's half the perimeter or the semi-perimeter. And that's it. The formula basically is just plugging in and doing out the calculation. Okay, so let's see if we can find the area of a triangle that has sides of 9, 7, and 5. Now, if you wanted, you could avoid Heron's formula. Okay, if you forgot it, you didn't remember it, this is a side, side, side triangle. What law do we use with side, side, side? Law of cosines. You could find this angle right here, or find any angle, and then you could use the formula we just had. 1/2 the product of two sides times the sine of the angle between. The reason you can't do it right now is because you don't know any of the angles. But if you wanted to do it that way, you could find one of the angles with law of cosines, go back to the formula on the other page. That's going to take a lot longer. Okay, so let's use Heron's formula. And the first thing I like to do is just find the semi-perimeter. So it's 1/2 9 plus 7 plus 5. Yep, if you add all these up, 9 and 7 gives you 16, plus 5 is 21, half of 21, 10.5. Now, fill it in. So it's the square root of s times s minus every side. Do it in any order you want, it doesn't matter. That's s minus a, s minus b, and s minus c. Okay, we are going to need a calculator, but I like just to simplify all the subtraction first. So 10.5. What's 10 and a half take away 9? 1.5. Okay, 10 and a half take away 7? 3.5. And 10 and a half take away 5? 5.5. Now we need our calculator. Okay, so type in the square root of 10.5 times 1.5 times 3.5 times 5.5. Okay, so it's about 17.5 4, 1, 2. And what do I need to make sure I put on the end of that? Unit squared. So for us, I think it's kind of hard to appreciate how much work this formula is really saving you, unless you look at the proof and see how long it is. But this formula really saves you a ton of time if you want to find the area of a side-side-side triangle. Without it, things would be a lot longer.
Can we use that instead of using the cosine?
Yeah. If it said to find the area of this triangle, you can do it any way you want. Okay, if you really want, you could sketch that triangle, find the height, and do 1/2 the base times the height if you want. Okay.
How do we find the height though? Because
Well, to find the height, let's see. You'd have to draw that triangle, and then you would, yeah, it'd be a lot of work. You'd have to find this side right here first, and then you'd have that. And then, actually, no, we have that. That's 5. You would have to find,
she's not doing it.
I'd have to think about how you do it. You have to find that dotted line right there. That's the height. Well, you know one side. If you could find this, but we don't know that. Well, that might be tricky to set up. You might have to call one of these sides x, and then this part right here is 7 minus x. I don't know. I'd have to think about how to go through it.
Just won't do it.
I would stick with Heron's formula. Okay. Any other questions on Heron's formula? All right. So for tonight, I'd like you on 443 to look at just these few problems: 1, 2, 5, 6, 13, 14. And 17 through 19. Okay, tomorrow we will start section 8.3. Totally different. We're going to be done solving triangles. Okay, this was our last day solving triangles.